Hello everyone, this is Meghasham Raju, Assistant Professor, Mechanical Department, Engineering College, Bikaner. As we have seen in the previous class, the basics of measurement and metrology, we have discussed what is accuracy and precision topics. Now, I'll be moving with the third chapter, which is nothing but the linear measurements. What are the different types of the linear measurements? But in this lecture, I'll be sticking on with the Introduction to Linear Measurements and Vernier Scale. So, generally, what is meant by the linear measurement? Generally, for a linear measurement, the measuring device parameter will be directly proportional to the measured device parameter. Generally, the linear measuring instruments are vernier caliper, screw gauge, vernier depth gauge, vernier height gauge. We will be calling these as an linear measuring instruments. Measuring instruments are designed either for the line measurements. Line measurements are nothing but your scale or simple ruler or a tape measurement. Even the vernier caliper is considered as a line measurement. And coming to the surface to surface measurement, which is nothing but a screw gauge. These calipers and dividers are not the direct measurements, they will be transferring the measurement. And moreover, the quality of the measurement not only depends upon the accuracy of the instrument, but it also depends upon how the person is handling the instrument and what application he is using and at what orientation he is using. So these things you have to keep in mind for the quality of the measurement. So coming to the design of the linear measurements, generally the modern industry demands the manufacturing of components and products at higher degree of dimension of accuracy and surface quality. While designing, you have to keep in mind that the linear measuring instruments should be accurate and it should be precise. Then at the same time it should be simple to operate and it should be at a lower price. So these are the main parameters which you need to keep in mind while you are designing any type of the linear measuring instrument. Generally, the instrument such as caliper depends upon the feel of the user. Good quality instruments, reliability will be promoting and good reliability, but it is ultimately the skill of an user how he is using. So definitely he should be trained before using any linear instrument. And moreover, the important element of the reliability of an instrument is the readability. Generally, we know that the scale, normal scale, will be having an least count of 1 mm or its resolution is 1 mm. When you compare with the micrometers, which will be providing a higher resolution compared with the vernier calipers as well as the scale, but the main disadvantage of the micrometer is having a very less range, but the vernier calipers is having a higher range. As you know that the vernier caliper is having an least count of 0.01 mm generally. So now coming with these vernier instruments, As we know that the steel ruler can measure up to 1 mm, then a maximum of 0.5 mm. Beyond that, if you just want to zoom the finer level of measurements, you can't do with a normal steel ruler or a tape measurement. So you have to go with a vernier caliper or vernier scale, whatever the device using a vernier scale. On the other hand, the vernier instrument, generally based upon vernier scale principle, can measure up to a much finer degree of accuracy. So we can tell that it can amplify the variations in the measurement finely. That's why it is called as an precise instrument. The vernier scale was invented by a French mathematician in 1631 by an Pierre Vernier. Later it was developed by an American physician called Joseph Brown. Yeah, that's what. You know that what is the least count of vernier is 0.01 mm or less. So now let us see the vernier scale. The vernier scale generally consists of the two scales, which is nothing but an main scale and an vernier scale. As you can see in this diagram, this is the vernier scale and this is the main scale. The main scale is having a general readings of your normal ruler scale, and the vernier scale generally will be having a 10 divisions. Now let us consider that 10 VSD equal to 9 MSD, which is nothing but 10 vernier scale divisions are equal to 9 vernier scale divisions. Here you can observe that the value of 1 VSD is less than 1 MSD. So these type of scales will be calling it as an forward vernier scale. And in the same way, if it is an opposite, if 10 VSD equal to 11 MSD, then we'll be calling it as an backward vernier. Here 1 MSD is greater than, one value of VSD is greater than 1 MSD. So now let us see how to calculate the least count in a vernier scale using vernier scale. So now if we consider the least count is defined as the minimum length or the thickness that can be measured with a vernier scale is nothing but a least count, or you can also call it as the minimum resolution. Now if we consider the forward vernier, NVSD equal to n minus 1 MSD as I have defined in the previous slide. Now 1 VSD equal to n minus 1 by n MSD. The least count is defined as the minimum length or thickness that can be measured. So 1 MSD minus 1 VSD is nothing but a least count formula. The formula for the least count. Here you can see the formula for the least count. Then the least count, if we just substitute VSD in terms of MSD using this formula, you will be getting least count equal to 1 MSD by n. Then the total reading equal to MSR is nothing but a main scale reading plus VC is nothing but where the vernier scale coincides with the main scale into the least count. So here if we take one example, in this scale, if you see, the vernier scale coincides with the main scale at the 4th reading. Okay. Now as we know that the total reading equal to MSR plus VC into LC, the least count equal to 1 MSD by n. Obviously we knew that. So that the least count can be calculated as 0.1 mm. So the total reading equal to 1 plus VC, where the main scale coincides with the vernier scale, into least count 0.1 equal to 1.4 mm. So this is where the vernier scale calculation of the least count from the vernier scale can be done. So even though the vernier instrument is particularly used in some laboratories and mostly in a tool inspection, but in a production, if you just want to use in a production, these vernier scales are not used, or vernier calipers are also not used. There we'll be using the limit gauges and the comparators. Okay. So guys, that's all for today. In the next class, I'll be going with an mechanical instruments. I'll be explaining you what are vernier caliper, then what is meant by an micrometer, what are depth gauges, height gauges, like that I'll be discussing in the next class. Then after that, intermediate instruments I'll be discussing. These limit gauges, slip gauges will be coming there. Okay, so guys, I'll be continuing with the next class. Thank you.